In this example, I want to show that the following are equivalent for an integer n. We're going to show that n is even if and only if 3n plus 1 is even, if and only if n squared plus 5 is even. I do feel obligated just to mention that the following are equivalent has a, I'm not a big fan of this, but an abbreviation TFAE. So I will not use this abbreviation, but just in case you ever see it, that's what TFAE really stands for, is the following are equivalent. So what we're going to do is we need to show that each of these statements implies each other. So at its heart, we really have 6 implications that we want to prove. We want to prove 1 implies 2, and 2 implies 1, and 2 implies 3, and 3 implies 2, and 1 implies 3, and 3 implies 1. So we have 6 things that we need to show, but we can actually get away sometimes with fewer things. So for example, maybe we could get away with 1 implies 2, 2 implies 3, and 3 implies 1. So if we could do that, then we'd be done, because we could go from any one statement to any other, right? And so by the transitivity of the implication, we could say that, for example, 1 implies 3, because we could go through 2 first. So that's one way that you could do this. What I mean by the transitivity of implication is that if we want to prove that 1 implies 3, well, we could say, well, 1 implies 2 and 2 implies 3. Therefore, if 1, then 3. So that's what I mean when I say that. In this case, we're not going to be able to go through and do these steps because 2 and 3 are kind of more complicated expressions. But what we can do is we can, and this will be our strategy, we can show that both of these statements are logically equivalent to statement number 1. So we can prove that 1 implies 2 and 2 implies 1, and 1 implies 3 and 3 implies 1. And so that's going to be our strategy. And I'm just going to sketch this out, and I'll leave you to fill in the details. So if I want to prove that 1 and 2 are equivalent, I need to prove that if n is even, that implies that 3n plus 1 is even. And we can do that with a direct proof. And I'll leave that to you to fill in the details. If I wanted to prove, so this is 1 implies 2. If I wanted to prove 2 implies 1, this means that 3n plus 1 is even, implies that n is even, and we could do that by contrapositive. Okay, so we could do that with the proof by contrapositive. And then 1 implies 3. We could do a direct proof, so that's n is even implies n squared plus 5 is odd. And then finally 3 implies 1. We would again do by contrapositive. N squared plus 5 is odd, implies that n is even. In other words, if n is odd, then n squared plus 5 is even, right? Because that's the contrapositive. The implication goes the other way. You negate each of the statements. And then putting all 4 of these together would give us our proof. Okay, so I have something similar to this typed up in the notes, so I'm not going to belabor this point anymore, but this is a proof by equivalence. One other thing I want to say is that frequently in math, statements come of this form. Statements come, say, where you have, say, 3n plus 1 is even, if and only if. Okay, so if and only if n squared plus 5 is odd. And what's missing is this first statement that you want to show that these are both equivalent to. And so if you can think of a statement that these are both equivalent to, then that implies that they're equivalent to each other, right? So you're kind of missing the fact that you want to prove that both of these are equivalent to saying that n is even. And I think that having it written like this can actually be very helpful when you're kind of given this problem and you're missing that missing link there, right? You have that first statement that's not there, that these are both equivalent to. So oftentimes in math, what we need to do is we need to come up with what's another statement that we can prove that both of these are equivalent to, and then that shows that they're equivalent to each other. Okay, so that's kind of another thing that we can do to prove that these two are equivalent to each other.